Welcome to this presentation of the Rotary Club of North Bethesda, Maryland, USA. Our club was established in 1974. We meet every Friday morning at 7:45 a.m., and we often invite guest speakers to give presentations on all kinds of interesting subjects. Please contact us through our website at nbrotary.org. And thanks for watching.
We have with us again today Bruce Davis. We've had him a number of times. He's a good friend, a photographer. His career was in law, and he retired from law quite a number of years ago. And he's always been interested in the outdoors and the wild and that sort of thing, and is very concerned about our planet. And he's a guy that I've looked to because he's always on top of all the most current information about our what we can do to reverse the climate problem we're facing. I'm pretty pessimistic about it because most people aren't even paying attention to it, and half the people who pay attention to it don't think it's a big deal, which is a big problem. I think we're not going to pay attention to it until it happens, and then it may be too late.
It is happening.
No, I know, but has it affected you, personally? That's when it becomes a real problem. And of course, a lot of the people in the country are seeing it last couple of years for the first time that a major portion of each portion of the country has been affected by climate change. So, and there's new research out that by looking at air particles in very deep cores of ice, they can tell the amount of carbon dioxide in the air by year, not by every specific year, but by hundreds of years. But they're looking at millions of years of data. And they're saying what we're going through now is about 50 times faster increase in carbon than's ever been experienced on the Earth's surfaces before. I know there's still doubting Thomases, but it's it's overwhelming evidence that we are doing it. And what's happening now? We're putting more coal-fired plants in India and in China. Although we're the major contributor in the world, the United States still is by far the major contributor to this problem. In past history, we're not today, but we have other nations that are increasing at a high rate. So we got a real problem. It is solvable, and Bruce, I'm starting a lecture here.
Yeah.
Bruce needs to get up and tell you what we can do in our personal life.
Well, thank you. It's good to be back. We're going to talk mostly about solutions today, not about the problem. I think people Ken has described the problem. I agree with him. It's pretty grim. And so, but we're going to talk about some possible solutions today. And how much time do I have?
Like 25 minutes.
25 minutes. Okay, that's plenty. So, only we have the first slide now. Okay, so the program today is Electrify Everything. This is a necessary response to the climate risks. Next slide.
8 kilowatts.
Yes, exactly. Already, that's what we're ready. Kilowatt. No. So we know how to stop global warming. We have to stop burning fossil fuels. That is the big problem. We're putting carbon dioxide in the air. Carbon dioxide traps heat. The heat changes the climate. and we all end up worse off. So we've got to stop burning fossil fuels. We need to electrify transportation, buildings, and industry. You need to produce electricity from non-fossil fuel sources. So that would be solar power, wind power. Right now, maybe nuclear power. If we're very lucky, fusion power.
How about ocean?
Ocean, that's a possibility. People are working at that.
Waves.
We have to reduce non-combustion greenhouse gases. So that would be gases like methane, nitrous oxide. Methane you get from oil wells, wasted fumes coming from oil wells after the oil's expired. Natural gas that we use to heat our homes is basically methane with a few impurities. Cows belch methane. The cow digestive system releases lots of methane. And one of the common suggestions for reducing the problem is to eat less meat. People eat less meat. There will be less cows there belching methane. And
less red.
Less red meat. I think chickens are good things. So we have to reduce non-combustion greenhouse gases. There's a lot of nitrous oxide that comes from fertilizer. We overuse fertilizer, need to use less of it. So that's another solution. And then finally, we need to preserve, restore, and build ecosystems that sequester carbon dioxide. So trees and vegetation suck carbon dioxide out of the air. They use it to make the bark and the wood and the substance of the plants. So we need to take very good care of our ecosystems that are helping us take carbon dioxide out of the air. So that's basically the overview of how we try to solve the climate. Let's see. And here's how electrification fits in. We need to do all electric buildings, and they produce few greenhouse gas emissions, and they use less energy than buildings heated with fossil fuels. And then we also need to convert our transportation to electric vehicles. They produce no direct greenhouse gas emissions, and they consume far less energy than fossil fuel powered vehicles. So even though we haven't totally switched to fossil fuel free electricity at this point, I think one of the takeaways from this program is that it still makes a lot of sense to use electric heating and electric transportation. And that is because the electrified building and the electrified vehicles are so much more efficient than fossil fuel powered vehicles or fossil fuel heated buildings.
Quick question. Thanks. What percentage of our electricity is produced by non-fossil fuels at this point?
That depends on where you live. And if you're in West Virginia, most of your electricity is produced by coal. And if you live in Wyoming, that's the same thing. Here in Washington, we get our energy from Pepco. Pepco is about 35% nuclear powered and 5% solar and wind powered. So about 40% of our electricity here is from non-fossil fuel sources. So that's how it breaks down.
Okay, can you give me, one thing I don't understand is the pros and cons of the batteries, like if you have an electric car, that people say the batteries take a lot of energy to produce, and how you're going to get rid of the batteries. What is the simple one?
The thinking is the batteries do take energy to produce. An electric car will have more of what's called embedded carbon in it because of the thing, because basically they're more expensive and they take more materials to build. After about 1 year of operation, the electric car becomes advantageous. If you use it by a year, you've made up for all the problems created in the extra carbon that goes into building air. So
Is that mainly because the electric motor that powers it is, no gears, no transmission, no wasted energy, and therefore it's so much more efficient that it uses less energy, and over a little bit of time, that makes up for the energy to produce the battery? Is that sort of the
that's what we're going to get to, and that's the answer. That's the answer. That's the answer. Okay, so next. This is a very interesting book that came out recently, and it's an inspiration for part of this talk. The author says America can reduce its energy use by more than half by introducing no efficiency measures other than electrification. So electrification saves energy. How electrification fits in: all electric buildings produce few greenhouse gas emissions, and they use less energy than buildings heated with fossil fuel. Same thing with electricity. They produce no direct greenhouse gas emissions. Of course, there's some carbon going into the air from the electricity that fuels these vehicles, but they consume far less energy than fossil fuel powered vehicles. Need to go the other way. Oh yeah, okay. So I just made these points so we can go to this. In Montgomery County, buildings and transportation cause 92% of our greenhouse gas emissions. So a place to start attacking greenhouse gas emissions are in transportation and in heating our buildings. One thing we can do is we can replace heating and air conditioning systems with electric heat pumps. And people aren't going to go out and do this right away because we've got furnaces and they have a certain useful lifespan, and it wouldn't be economical to just replace your furnace until it's worn out. But when the time comes to replace the equipment, it is very friendly to the environment to replace it with a heat pump. We'll talk about how they work. There's a 30% tax credit up to $2,000 to help you pay for a heat pump. Advance, please. They're more efficient than a gas furnace. Lower heating bills. No direct carbon emissions. And if you replace a gas furnace with another gas furnace, you are economically committed to putting carbon dioxide from your new furnace for another 15 to 30 years. So this just ensures that the climate's going to get worse. So next time, when the time comes to replace a furnace, I hope people decide to use a heat pump instead. Heat pumps can be up to 4 times as efficient as gas furnaces. So gas furnaces, the top illustration here, 1 kilowatt hour of natural gas with most furnaces will produce 0.8 of a kilowatt hour worth of heat. So gas furnaces are at least 80% efficient. Sometimes they get as high as 90 to 95% efficient, but that's the best that can ever be done with the gas furnace, because the gas furnace is basically taking fossil fuel, burning it, converting it to heat. So 100% efficiency is the upper limit. Electric resistance heaters, these are where electric current passes through a resistive wire, and that produces heat. So they can be up to 100% efficient. That's as high as they can get. An electric heat pump can be more than 100% efficient, almost ideally up to 400% efficient, because what the heat pump is doing, it's not producing heat, it's taking heat from the atmosphere or from the outside of your house or the outside of the building, and it's pumping that heat into the interior of the building. So it's you can think of it as a heat pump. It's a refrigerator that runs in reverse. What a refrigerator is kind of a heat pump. It takes the heat that's inside the refrigerator, pumps it outside the refrigerator into your house. And that's why the exhaust, when the air you get from the heat pump, the fan that's blowing it out, is hotter than it's in the house. What it's doing is it's pumping heat out of the interior of the refrigerator, and that heat goes into your house. So what a heat pump does, it takes ambient heat. There's always ambient heat. Usually, even when it's freezing or a little below freezing, there is still some heat outside that can be pumped into the house, and the heat pump will use an electric motor to do that. And we'll talk about that a little bit if we've got time. Next slide. So heat pump efficiency for an entire winter compared to other heat sources. This is from the Northeast Regional Energy Associates. They're a nonprofit that studies these things. And you can see that the heat pump for the entire winter, and this is for areas in the Northeast, it's about 250% efficient compared to, which is vastly more efficient than an oil boiler, a gas or propane furnace, or an electric baseboard heat. How do heat pumps work? So we'll now have a short lesson in thermodynamics. Next slide. Next advance, please. So heat from the ground, air, or water warms a refrigerant liquid, and so that would be the slide on the F where it says ambient heat, air, ground, and water. Let's talk about an air source heat pump. So heat from the air will evaporate this refrigerant, which is a chemical that has a very low boiling. That then goes into the compressor, cycles around into the compressor, which, advance the slide, please. The compressor increases the temperature and the pressure of the refrigerant. So this is what the electricity does. It compresses the vaporized refrigerant, and that will then become a very hot liquid. Then it goes, next advance, the refrigerant goes through a condenser, which is inside your house or building. And as the heated liquid cools, it's much hotter than the temperature inside your house, and heat flows from hot to cold. So the heat will go from this compressed liquid into your house. And then the final step is it goes through an expansion valve, which enables the refrigerant to expand again into a gas, and the cycle repeats. So that's basically how it works. And so, but it's basically no different from what a refrigerator does. You've got refrigerators in your house. I even learned that I have a heat pump in my dishwasher has a heat pump in it. I never realized that, but that's how they modern dishwashers heat the dishes dry.
Is the heating part of this, is that a liquid or is that air that goes through the house? So
it'll be a heat exchanger.
So like a radiator?
Well, it could be that would be a form of heat exchanger, but usually it would be so it would go into the air.
Refrigerator heats your house.
Yeah, refrigerator heat. Yeah.
But you still need ductwork and everything.
Yeah.
Doesn't it go through coils and there's a fan that blows air?
Yeah.
Coils?
Yeah. Like a refrigerator.
Yeah.
Yes.
Do the new heat pumps still have the emergency heat? The possibility of a switch?
And it is the air conditioner.
Some of Some of the new heat pumps do have what's called quick heating, which is often done by electric resistance. Sometimes it's done by fossil fuels, and sometimes they don't have that feature.
The same machine.
It depends on the climate, I understand. If you're in a real cold climate, you have to have the auxiliary. It's usually electrical. But they've got heat pumps so that doesn't kick in until about 20 degrees, below 20 degrees. It used to be they couldn't get that low, but they can now. So in this area, the heat pump is working normally without an auxiliary almost all the time. I was talking to a guy last night who specialized in that.
Sun sells heat pumps and
Yeah, my son has a
The
heat pump.
obstacle to transitioning is the cost of gas is so much less than the cost of electricity. Is that it?
I think they're very close right now in terms of the fuel costs. And I think the main obstacle to transferring to heat pumps right now is that the technicians are not so familiar with heat pumps. They've been installing furnaces all these years, so it's kind of hard to find a lot of heating companies that really know how to do this. I know GAC, who's my company, they are now advertising heat pumps, so it is becoming more common to use them. I think the biggest obstacle is the lack of training for heat and furnace installers.
There is another obstacle, and that is, for example, I was looking at my apartment, and my apartment was constructed many, many years ago. And for a heat pump, they have bigger coil systems. So it requires a bigger space to put a heat pump in. And the space that's allocated is too small for me to put a heat pump in my apartment. It has to go outside, but there's storage, and so you'd have to have all storage. It's just pretty unworkable. So there are some physical problems with the older buildings about converting when you wanted it.
Right.
I started.
And there are also some advantages because if you're doing a new building, you have to put a lot of less stuff in the house to get a heat pump system. You don't have to have a separate furniture. So
5 minutes.
yeah, 5
You
minutes.
have to do what with the new house?
5 minutes.
5 minutes. Okay, well, let's go.
I didn't hear what's.
Oh, I'm sorry. And heat pumps take a lot less space than furnaces. So if you're doing new construction, heat pump gives you more room inside the house.
That's inside, but outside they are big. My
Outside,
neighbor put 2 of them in.
yeah,
Outside is the addition. Yeah, different.
okay.
Yeah.
Soon heat pumps will be required on most new buildings in Montgomery County. We've just passed this year Bill 1322, which says the county executive is supposed to pass regulations that says new buildings will be all electric. So that's going to kick in about 3 homes through. Yes. Let's go to electric cars. We'll go a little faster. So advantages of electric cars, electric emissions 2/3 to 3/4 lower than gas, no air pollution emissions while driving, electric fuel costs a lot less than gasoline, low maintenance, fewer moving parts, no oil changes, no regular maintenance of the engines. You can fuel them at home with a 240 volt charger, which I do at my house. I just had the electrician install a charger. It's the same current as used in a dryer, and I can charge my car overnight. They are a lot of fun to drive. The acceleration can be flowing and very, very responsive. So let's go to the next slide. Gasoline vehicles inefficient. 68 to 72% of the gasoline's energy is basically lost. It's heat that the motor generates, throws off, goes up in the air. So mostly you're wasting the energy in the gasoline, and only 16 to 25% the energy actually goes to powering the vehicles. Let's go to electric cars. Electric cars are 87 to 91% efficient. And in addition to the inherent efficiency of an electric engine, electric cars have regenerative braking, which means when you put on the brakes, or even if you take your foot off the accelerator. The electric engine basically turns into a generator and converts the energy of the motion of the vehicle into electrical energy. So instead of a regular brake, which just basically uses friction and heats up, puts heat into the air, the electric vehicle saves that energy, stores it up in the battery, and is used to increase the car's efficiency. So let's go on. Let's skip this slide. I don't want to go into too much detail. There are three kinds of vehicles, or four kinds of vehicles actually. All electric, which just runs on batteries. Plug-in hybrids. So that's a hybrid vehicle like a Toyota Prius Plus, where it has a gasoline engine, but it also has an electric engine in it, and you can plug it in at home to put electricity in the battery. So that's a combination of electrical vehicle plus a hybrid. A hybrid vehicle is something like a Toyota Prius, which has a gas injection, but it also has a battery and the ability to generate electricity by braking. And then pure gasoline engines. And the chart on the right shows state averages for Maryland. So we start out on the left of the bar chart. An all-electric vehicle has got the lowest emissions per mile. And all of those emissions, which is the green part of the bar, that's the emissions from the electricity that went into powering the vehicle. Plug-in hybrid, you can see it uses a lot more emissions per mile. It still has some emissions from the electricity. And then most of the electricians come from burning gas. Then you have hybrids, and gasoline engines are, of course, have the most emissions per mile. We'll skip this. This is basically cost comparisons for electric versus non-electric. Go to the next slide. Electric vehicles have lower maintenance costs. There's no gasoline engine to maintain an electric vehicle. And I won't talk about all the advantages and disadvantages, but let's go to the last slide. If you want to learn more, this is a great place to go. Drive Electric Day in Poolsville, and finally go to the last slide. So when you need to get a new car furnace, hot water heater, or a clothes dryer, consider electrifying. We'll save money, we'll reduce emissions that foul the air and heat the planet. And tell your friends and neighbors too, because we need everybody's help to save our habitat.
Thank you.